morning, everybody. Today we're going to be talking about factoring. This is actually your activity. I'm going to be displaying off of it. I'm going to be teaching off of it. So if you're paying attention, you don't actually have to do most of it. There's a page at the end that is your actual activity today that I need you to complete. But if you watch this video, you will know that you don't need to complete the most of it, because most of it I'm going to be teaching you and going over with you today. I will know if you don't watch the video because you'll have to do more work. So it's a win-win for me. All right, we're going to learn all about factoring. All right, let's begin. On this page, I do need you to complete an activity. You need to list everything you know about factors. Everything. Before, during, and after this, you're going to learn about factoring. But right now, you need to just write everything you possibly know about factors. Okay? We're going to watch this video because, well, I know it's weird to watch a video inside a video.
20 million people use Grammarly every day.
But this guy does a really good job of teaching us. So we're going to listen to him so that I can interject and give you some pointers as well.
Hi, welcome to Math Antics. In today's lesson, we're going to learn all about factoring. Factoring is a math operation. It's something you do to a number. Now, with the other math operations you've done so far, you're given two or more numbers to work with. But with factoring, you only get one number. That's because factoring is like being given the answer to a multiplication problem and then having to figure out what that problem was. So you can think of factoring as unmultiplying. When you multiply, you take two numbers and multiply them together to get one number. And when you factor, you take one number and figure out what two numbers you can multiply together to get that number. For example, let's say you're asked to factor the number 10. Now that means that you need to figure out what numbers you can multiply together to get 10. If you know your multiplication table, you'll remember that 2 times 5 equals 10. That means that 2 and 5 are factors of 10. So factors are just the parts of a multiplication problem. And factoring is figuring out what those parts are. I'm sure some of you are wondering, why would I ever want to factor a number? Now that's a good question, and I have a good answer. Factoring can make solving some math problems easier. For example, factoring is really useful for simplifying fractions. By breaking a number up into its factors, you can sometimes cancel out factors.
We will need to know this later.
For now, though, you just need to learn what factoring is and how to do it. So let's see another example. Let's factor the number 24. For this one, I think I'll use my multiplication table. Let's see here. All right, well, 4 times 6 is 24. So that means that 4 and 6 are factors of 24. Now hold on. I'm sure some of you have seen that 3 times 8 is also 24. And that's true. We could have decided to factor 24 into 3 times 8 instead. So which of the factors is right? Is it 4 and 6 or 3 and 8? Actually, they're both right. There can be more than one way to factor a number. That's one of the things that might make factoring a little confusing at first. You're used to having just one right answer, because when you add, subtract, multiply, or divide, there is just one right answer. But when you factor or unmultiply a number, you might find that there's more than one correct way you can do it. So we can see that the number 24 has quite a few factors. 4 is a factor, 6 is a factor, 3 is a factor, and 8 is a factor. The fact that each of these numbers is a factor of 24 means that each of them can divide evenly into 24. And when I say divide evenly, I mean that it will divide in without the remainder. For example, if we take our first factor, 4, and divide it into 24 using a calculator, our answer will be 6. 4 divides into 24 6 times with no remainder. But what if we try to divide 24 by a number that isn't one of our factors, like the number 7? If we try 24 divided by 7 on a calculator, we get 3.42857, blah, 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 a long decimal number. That didn't divide in evenly because there's a big remainder. What we just did is called testing for divisibility. Testing for divisibility is a way to find out if a number is a factor of another number. With the test we just did, we confirmed that 4 is a factor of 24, but 7 is not. Sometimes you may be asked to find all the factors of a number. If that happens, you can use testing for divisibility to solve the problem. To see how it works, let's try to find all the factors of 24.
You will be asked to find all the
But
factors.
there's a lot more numbers we can test. Fortunately, we only need to test numbers that are less than half of the number we're testing. And since half of 24 is 12, we just need to test the numbers 1 through 12. To keep things organized, let's list the numbers we're gonna test, and we'll circle the factors that we already know. 3, 4, 6, and 8. We can also cross out the 7, since we already tested it and found out it wasn't a factor. Okay, now for the numbers we haven't tested yet. Let's start with 1. Well, of course 1 is a factor, because 1 will divide evenly into any whole number, so 1 is always a factor. And since 1 is a factor, then that means that 24 is also a factor, because 1 times 24 equals 24. It might seem weird that a number is always a factor of itself, but it's true. Knowing that helps you get started listing the factors, because you can always include 1 and the number itself. Now let's move on and test 2. If we divide 24 by 2, we get 12. So yes, 2 is a factor because it divided evenly. You can factor 24 into 2 times 12. That means that we can also circle 12 as a factor of 24. So, anytime you do a divisibility test, and the number you're checking passes the test, then the answer you get from dividing will also pass the test. It will also be a factor. That will speed things up, because we know we don't have to test 12. Okay, let's move on to the next number we haven't checked, 5. 24 divided by 5 equals 4.8. Well, that didn't divide evenly, because our answer is a decimal number. That means that 5 is not a factor of 24. Next, we'll try 9. 24 divided by 9 equals 2.66666.
I'm pausing it here because I noticed something, and this is what I tell all my students ever. When you have two numbers next to each other and the number in between them doesn't work, you're done, okay? When you are finding your factors and you found 4 is a factor, 5 is not a factor, 6 is a factor, now you're done. You got these two numbers, they're as close together as they can be. 9 is not going to work. We are seeing that right now. We'll watch and see if 10 and 11 work, but I'm telling you they won't, because as soon as you get numbers next to each other that are both factors, you're done. You have both sides of it, because you have 1 and 24, 2 and 12, 3 and 8, 4 and 6. You can't multiply anything else together because it will be bigger than 24, right? And you can't divide any of these by 24 because then it'll be a decimal number. So as soon as you get two numbers next to each other, and I know there's 5 in the middle, and 5 is in the middle, but since 5 didn't work, these are as close together as they can get. So now you know you're done. You're good. You have all your factors. Let's keep watching, because he's still testing to make sure that they're not right, and that's a good thing to do, to double check yourself, okay?
It's definitely not a factor. Okay, how about 10? 24 divided by 10 equals 2.4. Nope, that's a decimal number, so
Still
10
not a
is
factor.
not a factor. It looks like the last one we have to try is 11. 24 divided by 11 equals 2.181818. That's not a factor either. All right, since we've tested all the numbers that are less than half of 24, we found all of its possible factors. And they are 1, 2, 3, 4, 6, 8, 12, and 24. Now I know that might seem like a lot of work, but fortunately you probably won't have to do many of those problems. The important thing is just to know what factoring is and how you can use testing for divisibility to help you find factors. All right, that wraps up this lesson. But since actually doing math is the best way to learn it, be sure to try the exercise problems for this section. Thanks for watching, and I'll see you next time.
All right.
Learn more at mathantics.com.
Get ready.
Good. So we watched the video. Now we're ready to go on and practice ourselves. So on the first practice page, we actually have a multiplication table. Wow, Ms. Farmer couldn't remember her words. And it says find all the factors of 12. So when we started and he did 24 with his multiplication table, he went around and he found 24 in here. We're going to do that too, to make sure that we find all the factors. Nope, Ms. Farmer, get her good markers out. So let's go in and find 12. I found a 12. Found a 12. Oop, found a 12. Oop, found a 12. Oop, found a 12. And found a 12. Alright, so I circled all the 12 as the solutions. Now I'll just color them out so that you can really see where they're at, okay? They're all 12s, I promise. Now we need to find the factors that made that 12. What two numbers multiplied together gave us this 12? Very good. 1 times 12 gave us 12. What about this one? What two numbers gave us this number? What gave us 12 here? Very good. We had 2 times 6 equaled 12. And this one we had 3 times 4 equaled 12. Wait a second, 3 and 4 are next to each other on my number line, right? It goes 3 and then 4 right next to each other, right? Huh. Thought Miss Farmer said when I get to 3, when numbers are next to each other, then I'm done. Let's see why. So we did that one. Oh, these factors are 4 times 3 equal 12. 6 times 2 equals 12. That's a bad 6, sorry. And 12 times 1 equaled 12. Looking at these factors, these are all the factors of 12, but do you notice anything about them? Do you notice that these factors are the exact same as those ones above it? Because I found them again. I told you guys earlier, when you get to numbers that are right next to each other, it means you found all the possible factors. Because when you keep going, you just go to the opposite side. So instead of 3 times 4, we got 4 times 3. Instead of 2 times 6, we got 6 times 2. And instead of 1 times 12, we got 12 times 1. If I were to write these factors out, this is the first way they should be written. As a multiplication problem, showing me that they multiply together to equal the number that we're factoring. There's another way to list them as well. You're going to want to list them to make a rainbow. Miss Farmer likes to list them 2 ways. I like to list them like this. 1, 2, 3, 4, 6, 12. That way I know what they are. But then I like to have them horizontally. 1, 2, 3, 4, 6, 12. And I know that's kind of faint. I will get a new marker. But then we rainbow it to make sure that they match. The 1 is with the 12, the 6 is with the 2, the 3 is with the 4. Those are all my factors of 12. I found them using my multiplication chart. Why didn't I write all of these ones? I did, but we don't need to see 2 2s, and we don't need 2 3s, and we don't need 2 4s. We need each factor 1 time when we're making our list, and that's it. Alright? Miss Farmer's going to erase this, switch her screen, and get new markers because these ones are terrible. I'll be right back. Switch the screen and fresh markers. We'll just use black to be safe. Now we're going to find all the factors of 9. So we're going to go through again and we're going to find 9. Ready? Oh, there's a 9. We're always going to find a number here. Even when the numbers get too big for the multiplication chart, 1 times itself is always, always, always a factor, okay? No, don't see any 9s there. Oh, there's a 9. Oh, there's another 9. Okay. I only found 3 circles this time. I only found 3 9s in my whole multiplication chart. So we're going to start there. This is 1 times, very good, 1 times 9 equals 9. And we got 3 times, oh man, this is crazy. Hold on, look at this. It's 3 times 3 equals 9. Huh. 3 times 3 is very next to each other, isn't it? 3 is the same number, repeat it. There is no number in between that I could possibly have to test like happened in 24. And in 12, there was 3 and 4, which were right next to each other. 3 times 3, I should know I'm done, right? They're the same number, repeat it. There shouldn't be any more that work. But let's look, because I got one more circle down here. Oh, it's 9 times 1. Do I already have 1 and 9 as factors? Yeah, So do I need to write 9 times 1? I can, but I don't need to. I already know that those are factors. I already have them written down. So then when I go to list my factors, I would have 1, 3, 9. Huh. Why didn't I write 3 twice? Because 3 times 3 equals 9. But 3 is just one factor. 3 is one factor of 9. You don't need to write 3 twice. You do in the multiplication problem. But when you're listing the factors, you don't need to write them twice. It's just like back when we had 3 times 4 equaled 12 and 4 times 3 equaled 12. We didn't write 4 twice and we didn't write 3 twice. Because you didn't need to, you already had one of each listed. I already have 1, 3 listed, I'm good. Now it does make our rainbow look a little weird because we have 1, 3, 9, and our 1 and our 9 gets a rainbow, but our 3 is just rainbowed by itself because it is its same factor. So that makes our rainbow way less cool, but it still works. Alright? Let's move on. We're going to skip finding the factors of 10. I think you guys can do that one. And 6, you guys should be able to do that. Here are divisibility rules. This comes exactly from your Accelerate page. So these will help you. They're kind of like shortcuts. They're cheats. Like if you're playing a video game, these are your cheats. These are your shortcuts. These will help you so much. Alright? Any number that ends in an even digit, 0, 2, 4, 6, or 8, is divisible by 2 every single time. Every single time. Alright? If the digit sum is divisible by 3, then the digit number is divisible by 3. So if I had a number like 12, we'll go with 12 because it's smaller and easy, and the number is 12. If I add up these digits, so I really go 1 plus 2, what does it equal? Very good, 3, which means it's divisible by 3. If I had a number like 18, I could do the same thing because 18 is 1 plus 8, which equals 9, and 9 is divisible by 3. Okay? So if this, we should know that 18 and 12 are divisible by 3, but in case we get to a really big number, such as they did 894, when you add up 8, 9, and 4, you get 21, which is divisible by 3, so you should know that 894 is divisible by 3. You wouldn't know that just off the top of your brain. You wouldn't look at a number 894 and be like, yeah, that's divisible by 3, I know that, I'm so smart. No, nobody knows that, nobody's that smart, alright? That's crazy. But you should be able to do the cheats, add it up, and find out that, oh man, it is divisible by 3. Let me get out a calculator, divide it by 3, and find out what it is. Okay? Make sense? There's also divisibility by 5. If it ends in a 0 or a 5, it's always divisible by 5. Any number that is any even number that is divisible by 3 is also divisible by 6. Has to be even, can't be odd. Some of the divisible by 3 numbers are odd. For 6, it has to be the even ones. Take the last digit in a number, double and subtract the last digit in the number from the rest of the digits. What? I don't think I ever learned this rule. So in 357, we double the 7 to get 14. We subtract 14 from 35, which are the other 2 digits, to get 21, which is divisible by 7. So 357 is divisible by 7. That's a really cool cheat. Miss Farmer never knew that one. A number is divisible by 8 if the ones digit plus twice the tens digit plus 4 times the hundredths digit is divisible by 8. So in 6016, the last 3 digits are divisible by 8, so 6016 is also divisible by 8. Cool to know. If the digit sum is divided by 9, then the number is divisible by 9. So this is kind of like the 3, if you add them all up, and you get a number that you can divide by 9 evenly, then the big number is divided by 9 evenly. Any number ending in 0 is divisible by 10. That's a super easy one. Alright, so these are just kind of cheats to help you out, to help you learn faster. you are going to find all the factors of 18. Now, we don't have the multiplication chart anymore, but you do have your divisibility rule. So 18, I just gave you someone on the last slide. So make sure you're doing this page. You must do this page, and this page, and this page, and then lastly, this page, okay? So you guys are responsible for slide number 1. You're responsible for the very first slide. You guys remember that when I asked you to let me know everything you know about factors? You're responsible for that slide. And then you're responsible for slide 9, 10, 11, and 12. 9, 10, 11, and 12. So if you don't watch the video and you have to do all the slides, that stinks. Make sure you're watching my lessons so you only have to do 5 slides today, which should be pretty simple. Take your time, try your hardest. Good luck, guys.